All right, let's start with a little thought experiment. What if we could change just one single fundamental rule of the universe? Today, that's exactly what we're going to do. We're going to engineer a super Earth, and you are not going to believe how one little tweak changes, well, everything.
So what's this big change? It's actually super simple. We're just gonna double gravity. Seriously, just imagine for a second. You wake up tomorrow and everything, including you, feels twice as heavy. What would that even be like?
And look, this isn't just about feeling kind of sluggish or having a tough time getting out of bed. No. This one change sets off a chain reaction, a total overhaul of the basic physics of existence.
So on this new super Earth, every single object, from a tiny rock to a massive building, is being pulled down with double the force. So to do something simple like lifting this block, you now need twice the force. And what does that mean? It means it costs you twice the energy.
And that's really the heart of the matter. This one change doesn't happen in a vacuum. Oh no, it kicks off this incredible domino effect, a whole cascade of consequences that would totally remake not just our tech, but the planet itself. Because think about it, before any intelligent species can even think about building things, it has to deal with the world around it. And on a 2G world, well, nature itself would look completely, fundamentally different. Let's just look at the natural world. You know our giant, towering redwood trees? Yeah, those would be totally impossible. Their own weight would literally crush them. So you'd end up with these shorter, much stockier forests. And it's the same deal for mountains. They just collapse under their own mass, leading to a much flatter, more worn-down landscape. Even water would act differently. It would flow way faster, carving out these incredibly deep canyons.
Okay, so given all that, how would an intelligent species even begin to build in a world like this? Well, for one thing, forget about our sleek, tall skyscrapers. They'd be ridiculously unstable. They just couldn't hold themselves up.
To deal with twice the weight, architecture would have to get, well, a lot beefier. Buildings would have to be shorter, way wider, and most likely shaped like pyramids to distribute all that load. And what about bridges? You'd need massively thick cables, super strong pillars, and foundations that are just enormous, all just to keep them from collapsing. And this whole principle, stronger, thicker, heavier, it applies to literally everything. Let's take something we see every day, like a car. Okay, so your standard car, its effective weight just doubled. The tires would pretty much flatten out, the suspension would just collapse, and the brakes, they'd need to be way, way more powerful to stop all that extra downward force.
And this is where you start to see the huge industrial challenges. Take a simple robotic arm, right? One designed to lift, say, 10 kilograms. Well, now it's fighting against 20 kilograms of resistance. That means you're going to need bigger motors, a lot more torque, and you're going to get this massive increase in friction, which means parts are going to wear out ridiculously fast. But here's the thing. Every single one of these solutions, every stronger pillar, every thicker tire, every bigger motor, it all comes at a cost.
Because when every physical action takes double the work, the basic energy demand for an entire civilization just skyrockets. We're talking exponentially higher. Factories, cities, you name it, they would need fundamentally more powerful energy sources just to function. And this constant, relentless pull creates one last, absolutely massive challenge. How do you get off the planet?
See, here on Earth, we can get into orbit using chemical rockets. It's tough, but we do it. But on a super Earth, the sheer volume of fuel you'd need to fight that gravity, what engineers call the mass penalty, it's just astronomical. Trying to launch even a tiny satellite would be incredibly difficult. This is the gravity trap.
So to have any hope of escaping, a civilization would have to pretty much skip chemical rockets altogether. They need to jump straight to really advanced, almost theoretical tech, things like nuclear propulsion or maybe even giant space elevators, just to get into orbit.
All right, let's kind of recap here. Compared to Earth, a 2G planet forces you to have heavier vehicles, shorter, sturdier buildings, industry that's constantly fighting friction, an absolutely insane demand for energy, and it makes spaceflight pretty much a non-starter with our kind of technology. And this whole thought experiment, it leads to a really profound idea. Scientists estimate that a lot of the super Earths we're finding out there in the galaxy have gravity that's 2, maybe even 3 times what we have. So if intelligent life is out there on one of those worlds, their entire technological development would be dictated by this constant, crushing force.
Think about it. They could build these amazing cities, develop incredibly complex machines, have a deep grasp of science, and yet they could be permanently trapped, locked inside their own gravity well. Which leaves us with one last, pretty provocative question.
Something to think about, right? Hey, thanks for diving into this massive idea with us. Next time you're looking up at the night sky, just remember this. Maybe, the silence we hear from the cosmos isn't because we're alone. Maybe it's because the most advanced civilizations out there are simply grounded. We'll catch you on the next Explainer.